Imagine being able to travel 100 years into the past and meet your great-grandfather, or journey 1,000 years into the future to witness the destiny of humanity. It sounds like science fiction, doesn't it? But what if I told you that time travel isn't just a fantasy? It's mathematically possible within the framework of physics. Einstein's theories of relativity have opened doors to the possibility of time travel. Today, we'll walk through those doors and explore the scientific foundations of time travel. First, let's clear up a common misconception. Time is not a fixed, unchanging arrow. Einstein's 1905 theory of special relativity showed that time is not absolute. Moving clocks tick slower. This isn't just theory, it's a reality we correct for every day in GPS satellites. How does it work? Space and time are united in a four-dimensional fabric called spacetime. This fabric can be warped by mass and energy. More mass/energy means more warping, which means slower time. So forward time travel has already been proven. You've probably heard of the twin paradox. One twin stays on Earth while the other travels through space at near light speed. When the traveling twin returns, they are younger than their Earth-bound sibling. This isn't a paradox, it's physical reality. How does it work? There are two ways. First, velocity. If you travel at 99.9% the speed of light, your time slows down relative to Earth by a factor of 22. Second, gravity. Time passes slower near a black hole. 1 hour near the Sagittarius. A star black hole is about 7 years on Earth. That's why in the movie Interstellar, the astronauts were younger when they returned from the black hole. Now, let's get to the really interesting part, traveling to the past. Theoretical physics suggests two possible methods. First, wormholes, tunnels that fold space-time. Under the right conditions, these tunnels could open into the past. Second, closed timelike curves, CTCs, paths that loop back in time, formed around rotating massive objects. However, there are major problems. First, keeping wormholes open requires exotic matter with negative energy density. Second, the grandfather paradox. If you go back in time and kill your grandfather, how do you exist? Physicists propose the consistency principle to resolve this. A time traveler cannot change the past, but only becomes part of what has always happened. Quantum physics offers even stranger possibilities. First, quantum tunneling could allow microscopic time travel. Second, the many worlds theory suggests that changing the past might create a new parallel universe. In 2020, scientists at the University of Bristol sent signals backwards in time using photons on a small scale. But the biggest obstacle is energy. Sending a human back in time might require the energy of an entire galaxy. Also, Novikov's self-consistency principle states that even if time travel is possible, it won't allow paradoxes. So you couldn't go back and kill Hitler because you come from a past where Hitler wasn't killed by you. In summary, forward time travel to the future is physically possible and proven. Backward time travel to the past is theoretically possible, but faces enormous practical hurdles. Perhaps the greatest lesson of time travel is this: time is not a river we can travel on, but an ocean we swim in. Every moment we are both the product and the creator of this ocean. This video exists thanks to curious minds like yours. If you want to learn more about time travel, I recommend Stephen Hawking's A Brief History of Time and Kip Thorne's The Science of Interstellar. Next week, we'll explore mind-reading technologies, science fiction or reality. Subscribe and turn on notifications so you don't miss our future videos. Remember, the greatest journey begins in your mind. Keep learning.